Welcome back to the first year chemistry. In this video, we'll start with the chemical bonding and molecular structure. So as far as this chemical bonding and molecular structure chapter is concerned, we will deal with so many subtopics in this chapter, like the Lewis structure and Lewis theory, that is causal and Lewis theory for formation of the chemical bond, which actually considers the octet rule. And then we will go for the different types of bonds, like the covalent bond, ionic bond, coordinate bond, and finally we will deal with the dative bond, which is also called as the coordinate bond, and hydrogen bonding. And various theories are considered to explain the formation of the bonding between the two atoms. So we will consider these topics, and then we will consider the formal charge on the central atom or different atoms present in the molecule. Suppose there is a carbon atom linked to another atom, then even though there is no actually charge present on the atom, we will calculate, for some purpose we need to calculate the charges on each atom. And then we will go for the coordinate bond in detail, and also the properties of the covalent compounds, properties of the ionic compounds, and also we will deal with the ionic nature in the covalent molecule and covalent nature in the ionic compound. And then we will go for the molecular orbital theory. To explain finally how a stable molecule is formed, we will consider the molecular orbital theory. And to explain all these, we come across some more types of theories, like the valence shell electron pair repulsion theory, that is VSEPR theory. So to write the various concepts that we consider in this topic, we will consider these topics to be covered. That is, we will consider these topics to be covered in this chapter, and based on which we may expect so many questions in the topic. The first one is causal and Lewis theory. Causal and Lewis theory. Under this one we will consider the octet rule. Octet rule. And then we will consider the types of bonds. Types of bonds. And then we will consider the Lewis concept, Lewis structures. To explain the formation of the molecule, we will consider these Lewis structures. And the second point that we consider is the formal charge. Formal charge on atoms in a molecule or ion. We will consider the charge on each atom. Then the next one is polar and non-polar molecules. Polar and non-polar molecules. Then we will consider the next topic, dipole moment. So in the polar molecules, we will consider this dipole moment. Dipole moment. Then we will consider partial ionic character in a covalent molecule. Partial ionic character in a covalent molecule or in a covalent bond, we can say. And also we will consider the reverse, partial covalent character in the ionic bond. Partial covalent character, partial covalent character in an ionic bond. So when we look into these 2 points, we consider that in any covalent molecule there is a partial ionic character. In ionic molecule there is a covalent character, partial covalent character. That means no any molecule is purely ionic or purely covalent. So there may be extension of nature of the covalent character or ionic character in a molecule. Then we will consider this VSEPR theory. VSEPR theory. That is valence shell electron pair repulsion theory. Then we consider hybridization. Hybridization. So, to explain the formation of the molecule with equivalent bond length and so many other bond properties, we will consider that concept of hybridization. Then we will go for this molecular orbital theory. Molecular orbital theory. So these are the various topics that we come across in this particular chapter, and under the topic different types of bonds, we will consider this type of bond, that is a special one, that is hydrogen bonding. Hydrogen bonding. We will not consider the detailed explanation under these types of bonds for this hydrogen bonding, because it needs a special explanation. In what case that hydrogen bond is formed, in what type of compound that hydrogen bond is formed, and how that hydrogen bond explains the certain characteristic properties of the various molecules. Now, first let us consider this Kossel and Lewis theory, that is regarding this octet rule. When you consider any atom, it may possess an electron or more than one electron in an orbital, that is outermost orbital, which gives instability to that atom. That's why that atom will try to gain the octet. In case of the hydrogen, it is called duplet, so that it becomes the stable configuration. Say for example, when we consider this hydrogen atom, we will consider this first Kossel and Lewis theory. When you consider this hydrogen atom, we know that it has one electron and one proton. One proton is present in the center of the nucleus and one electron is revolving around the nucleus. For the first orbit or orbital, the capacity is 2 electrons, but it has only one electron. That's why this hydrogen atom is highly reactive or highly unstable. So it will try to gain the duplet either by absorbing the electron from other atom or by giving out the electron. Once it takes up one more electron from the other atom, it becomes 2. So its configuration becomes stable. Let's just compare with the helium atom. In case of the helium atom, the configuration is 1s2. That means in the center there are 2 protons and in the first orbit there are 2 electrons. Hence the helium atom is highly stable. It is highly unreactive towards various reactants. That's why to explain the stability of this helium atom, we consider this a duplet theory. According to this octet, Kossel and Lewis theory, since it has only 2 electrons in the first orbit, it neither loses the electron nor gains the electron because it is highly stable. But in case of the hydrogen atom, there is only one electron. So it may either lose the electron so that the orbit becomes empty, or it may gain one electron so that it attains the configuration 1s2. That is the reason why this hydrogen atom undergoes certain reactions. Similarly, when you consider this sodium atom, in sodium we have actually the atomic number 11. The configuration is 1s2, 2s2, 2p6 and 3s1. Since only one electron is present in the third orbit, in case of the sodium atom, it is highly unstable, it is highly reactive. That's why the sodium will try to lose the electron easily rather than gaining the electron, because the electron is present in the third orbit. So it is better to lose the electron from the sodium rather than gaining the electron by the sodium atom. So once this loses the electron, it will become sodium with positively charged. This electron is taken up by another element which gives rise to the negative ion. So while explaining this Kossel and Lewis theory, we consider this octet or duplet rule. Since this electron is lost from the sodium atom, the next orbit containing 8 electrons gives the stability to the sodium ion. That's why sodium ion is more stable as compared to sodium atom. So since it attains the octet, it becomes stable. Now to explain these types of bonds, since to attain the duplet or octet, an element either loses the electron or gains the electron or shares the electron with the other element. So based on this one, we have actually mainly two types of bonds. The third type of bond is actually again the donation of the electron but pair of electron. So we consider these two. First one is the ionic bond. The second one is covalent bond. The third one is the coordinate bond. Since these two, ionic bond and covalent bond, are important as far as the formation of the molecules are concerned. This third type of bond, coordinate bond, is nothing but extension of the covalent bond. That's why it is also named as the covalent coordinate bond. Now let us consider how this ionic bond is produced or how ionic bond is formed. So to consider that one, we will consider some elements which are having certain characteristic properties. Those characteristic properties are, if an element possesses a very low ionization energy, usually we consider this first and second group metals. First and second group elements, which are nothing but metals, alkali and alkaline metals. So when you consider this atom like sodium, so we are considering now the explanation for the ionic bond. When you consider this sodium atom, as I have already explained here, it contains 1s2, 2s2, 2p6 and 3s1. Since this only one electron is present in the outermost orbit of the sodium atom, to remove this electron it is very less energy required. That's why this sodium has got low ionization energy. Once it loses the electron, it becomes Na+. Now in the Na+, we have got this 1s2, 2s2, 2p6 configuration. So this is an example for the octet rule. Since octet is complete, the sodium ion is stable. Once this electron is lost, there should be another atom which gains the electron. So for example, you consider this chlorine atom. It has got 1s2, 2s2, 2p6 and 3s2, 3p5. Now you observe there are 7 electrons in the outermost orbit. Again it requires one more electron for the completion of the octet. That's why this chlorine atom takes up one electron to give rise to Cl- ion. So to absorb the electron easily, it should possess high electron gain enthalpy. In the chapter called the classification of the elements and the periodic properties of the elements, I have explained what is electron gain enthalpy, ionization energy, etc. The energy required to remove 1 mole of electron from the isolated gaseous atom, it is called as the ionization energy. So you consider 1 mole of sodium atom. Instead of 1 atom, you consider 1 mole in the gaseous state. To remove the electron from 1 mole of the sodium atoms, to give 1 mole of sodium ions in the gaseous state. Whatever the energy that is required, that is called as the ionization energy or ionization enthalpy or ionization potential. So since sodium atom in the gaseous state easily loses the electron, very less ionization energy is required. So in case of the electron gain enthalpy, when you consider 1 mole of gaseous chlorine atoms in the isolated gaseous state, you consider 1 mole of sodium chlorine atoms to give rise to 1 mole of chloride ions in the gaseous state. Whatever the energy that is released, it is called as the electron gain enthalpy. Ionization energy, since it is the energy absorbed, it is always a positive quantity. Electron gain enthalpy, usually it is a negative quantity because it is energy released. So once this ionization energy, low ionization energy atom loses an electron, high electron gain enthalpy atom gains the electron, the ions are produced. Now once it gains the electron, the configuration will become 3s2 3p6. So it attains again the octet rule. Once this sodium ion is produced and chloride ion is produced in the gaseous state. So they will come close together because of the opposite charges. They are attracted by one another to give rise to this sodium ion and chloride ion held by certain force of attraction. This force of attraction which holds the oppositely charged ions together is called the ionic bond. So sodium ion and chloride ion, because of the opposite charges, they are held by certain attractive forces. So that attractive force which results in the formation of the sodium chloride molecule is called the ionic bond. And such compounds are named as the ionic compounds. Ionic compounds. So in the periodic table, we know that first and second group elements have got the very low ionization energy. And usually 16th, 17th group elements, they possess 16th and 17th group elements. They possess high electron gain enthalpy. That's why the ionic bond is produced between the first and second group elements of the periodic table with 16th and 17th group of 16th and 17th group elements of the periodic table. So such molecules produced are named as the ionic compounds. Simple. An element which loses an electron will become a positive ion. An element which gains the electron will become a negative ion. The force of attraction between the positive ion and negative ion giving rise to a molecule is called as the ionic bond. It is also named as the electrovalent bond. Electrovalent bond. And this number of electrons lost and number of electrons gained by the elements will give rise to valency. Since transfer of the electron takes place between the element with low ionization energy and element with the high electron gain enthalpy, it results in the formation of the ionic compound that is called as the electrovalent.